We're going to take a look at the learning topic, I can add and subtract polynomials. So what you need to know, polynomials are added and subtracted by combining like terms. So you need to be sure that you understand the idea of what a like term really is. So here are some examples on the left of things that are like terms. Notice that my variable parts are all the same. So here I have 2 x's and here I have 19 x's. So I can add all of the x's together. I'd have a total of 21 x's. Whereas on the other side here, the unlike terms, I have 2 x's, but then I have 2 a's. Well, I can't add x's to a's. They're not the same. You can't like add apples and oranges together because they're not all apples or all oranges. We count them separately when we're identifying them. Same thing when we have variables. So anything that has the same variable part, those are like terms and we can put them together. And then you just do what the symbol tells you. So if I had 4w minus 10w, I would just subtract. 4 minus 10 is negative 6, so I'd have negative 6 w's. Same thing when we have exponents. So here I have a squared. It's the same type of variable, so I can add the numbers out front, as opposed to over here on the right, I've got a squared and a to the third. Those are not the same. I cannot add the coefficients together. So let's look a little bit more in depth on how we would add or subtract our. Okay, so in our first example, we're going to add and or subtract the polynomial. So here's our first example. Notice here we have a trinomial. There's 3 terms here, and we're adding it to another trinomial. So let's take a look at how we would do this. The first step is to distribute the sign if it's negative. Well, if we look clearly here, the sign in between both of my trinomials is a plus sign. So I don't need to distribute it because all of the signs are going to stay the same because I'm adding all of those parts. So the next thing I want to do is to drop my parentheses. So I'm just going to rewrite my problem without the parentheses. I'm taking them away. Now you'll also notice here that I've color coded. So what I've done is I've taken a look at everything that is a like term. So here I have k to the 4th, and here I have k to the 4th. So those are like terms. I can add them together. My 14 is a constant term because it doesn't have a variable part. Same with the negative 8. I can put those together. And then lastly, my k squareds. These are like terms, so I can add those coefficients together. So that's what we're going to do in the next step. We're going to combine those like terms. So when I do that, if I look at just these 2 parts here, negative 4 k to the 4th minus 3k to the 4th, well, that's going to give me that negative 7 k to the 4th. You can do the same, apply the same principle here to the 14 and the 8. So 14 minus 8 gives me this plus 6. And then 3k squared minus 12k squared, 3 minus 12 gives me negative 9. So that's where I get all of those parts. Now when we're writing the answer to a polynomial, we typically like to write it in standard form, or if you have a multiple choice test, you're going to see it written in standard form. That is the answer. And standard form just means that you're putting things in order of degree. So I start with the highest degree, which is that negative 7k to the 4th. But then my next highest degree is the k squared term. So I'm just rewriting it minus 9k to the 2nd and then plus 6 at the end. We always put those constants last. All right, now here's an example. Instead of adding, notice this time we are subtracting. So that value or that symbol in between here is a minus sign, which addresses our first step. We want to distribute that sign. So basically we are kind of shooting the rainbow of the negative to everything inside of this trinomial, which means all of the signs are going to change. So when I change this to a plus sign, I've also changed the sign inside all of these parts. So notice now I have a plus, and a minus. Second step, we can drop the parentheses. So I've taken that same polynomial that we're adding, and now I've color coded my like terms. So I've got 3 out here. It's a constant. There are no other constants in this problem. That's why it's the only green term. End of the 5th, I look for any other terms that are end of the 5th, and over here in yellow I have that negative 8 n to the 5th. Okay, so that's why I have those both in yellow. And then my n to the 4ths, I have 2 of those terms. And then my single 3 to the n's, I just have 1 of them. So now we're going to go ahead and combine those like terms. And so when I do that, I'm going to start with, I just kind of go down the line in order. 3 didn't have anything, but my n to the 5th, the yellows did. So negative 6 n to the 5th minus 8 n to the 5th gave me negative 14 n to the 5th. Then my n to the 4th terms, negative 8 plus 6 gives me negative 2. And then when I have that n to the, or 3n left, there's nothing else there. I just tack it on the end. And just a reminder, when you are adding your polynomials together, you do not change the value of your exponent ever when you're adding or subtracting polynomials, okay? Now we're just going to rewrite it in standard form. My highest degree here is this n to the 5th, so that guy's going to go first. Negative 14 n to the 5th minus 2 n to the 4th plus 3n plus 3. All right, so example 2, you could pause, try, and check these on your own. As we're going through them, we're going to do the same idea, add or subtract the polynomials. So here's our first example. Again, we have 2 trinomials that we're adding. They're trinomials because there are 3 terms in each of these parts. Okay, step 1, we want to distribute that sign. Well, I have a plus sign. I don't need to distribute anything, so I can just go ahead and drop the parentheses. If you're someone who likes to color code or highlight, I highly recommend. Another thing that I would do, if I don't have any colored pencils or highlighters with me, is I just use different shapes. So my r to the 3rds, I might circle, and then I might box my r to the 2nds, and then I might use a triangle around r, just my single r's. And that kind of helps identify them as well, for those of you who are a little bit more visual. Then we go ahead and we combine our like terms. So my red here, my circles are 9r to the 3rd minus 2r to the 3rd. That leaves me with a 7r to the 3rds. Then I have my r squareds, 5r squared minus 8r squared is going to give me negative 3r squared. And then 11r plus 9r, that gives me a total of 20r's. This is already written in standard form. Notice I've got my highest degree first, and then it's decreasing. So 3, 2, 1 for my degrees. It's already there. I don't need to rewrite it. Part B, if you want to stop, try this one on your own and then come back and check. Feel free. Again, I have 2 trinomials because I have 3 terms in each set of parentheses here. But this time I have this minus sign, so I need to distribute that negative. I need to change the sign of everything inside. So when I do that, it becomes a negative 3n, a negative 11, and then a positive 7. I've just switched all of the signs inside. I can go ahead and drop my parentheses and start to color code. Once I've done that and I've identified all my moving parts, I can go ahead and then start combining. So 8n, there are no other single n terms, so that's just going to stay 8n. My n to the 4th, I have negative 3 and negative 11, which gives me a total of negative 14. Then I have my n squareds. I've got 10 minus 3, which gives me that 7n squared. And then I just have one constant left over, so that guy just gets tacked onto the end. It's not written in standard form, so I'm going to go ahead and do that. My highest degree is 4, so I'm going to put that guy first. Negative 14 n to the 4th, and then plus 7n squared, plus 8n, and then plus 7 at the end. We always put those constant terms at the end. If you want more on this topic, you can check out the Learning Target spreadsheet for additional resources, videos, and practice.